Sir Isaac Newton, 25 December 1642 – 20 March 1726/27, was an English mathematician, physicist, astronomer, theologian, and author, described in his own day as a natural philosopher, who is widely recognized as one of the most influential scientists of all time and as a key figure in the scientific revolution. His book Philosophiae Naturalis Principia Mathematica, Mathematical Principles of Natural Philosophy, first published in 1687, laid the foundations of classical mechanics. Newton also made seminal contributions to optics, and shares credit with Gottfried Wilhelm Leibniz for developing the infinitesimal calculus. In Principia, Newton formulated the laws of motion and universal gravitation that formed the dominant scientific viewpoint until it was superseded by the theory of relativity. Newton used his mathematical description of gravity to prove Kepler's laws of planetary motion, account for tides, the trajectories of comets, the precession of the equinoxes, and other phenomena, eradicating doubt about the solar system's heliocentricity. He demonstrated that the motion of objects on Earth and celestial bodies could be accounted for by the same principles. Newton's inference that the Earth is an oblate spheroid was later confirmed by the geodetic measurements of Maupertuis La Condamine and others, convincing most European scientists of the superiority of Newtonian mechanics over earlier systems. Newton's laws of motion, relations between the forces acting on a body and the motion of the body, first formulated by English physicist and mathematician Sir Isaac Newton's third law states, for every action there is an equal and opposite reaction. A variety of action-reaction force pairs are evident in nature. Consider the propulsion of a fish through the water. A fish uses its fins to push water backwards. But a push on the water will only serve to accelerate the water. Since forces result from mutual interactions, the water must also be pushing the fish forwards, propelling the fish through the water. The size of the force on the water equals the size of the force on the fish. The direction of the force on the water backwards is opposite the direction of the force on the fish forwards. For every action, there is an equal in size and opposite in direction reaction force. Action-reaction force pairs make it possible for fish to swim. Consider the flying motion of birds. A bird flies by use of its wings. The wings of a bird push air downwards. Since forces result from mutual interactions, the air must also be pushing the bird upwards. The size of the force on the air equals the size of the force on the bird. The direction of the force on the air downwards is opposite the direction of the force on the bird upwards. For every action, there is an equal in size and opposite in direction reaction. Action-reaction force pairs make it possible for birds to fly. Consider the motion of a car on the way to school. A car is equipped with wheels that spin. As the wheels spin, they grip the road and push the road backwards. Since forces result from mutual interactions, the road must also be pushing the wheels forward. The size of the force on the road equals the size of the force on the wheels or car. The direction of the force on the road backwards is opposite the direction of the force on the wheels forwards. For every action, there is an equal in size and opposite in direction reaction. Action-reaction force pairs make it possible for cars to move along a roadway surface. The frictional force is equal and opposite to a force applied by car. It helps the car to move forward. Like all objects, rockets are governed by Newton's laws of motion. The first law describes how an object acts when no force is acting upon it. So, rockets stay still until a force is applied to move them. Likewise, once they are in motion, they won't stop until a force is applied. Newton's second law tells us that the more mass an object has, the more force is needed to move it. A larger rocket will need stronger forces, e.g., more fuel. To make it accelerate, the space shuttles required 7 pounds of fuel for every pound of payload they carry. Newton's third law states that every action has an equal and opposite reaction. In a rocket, burning fuel creates a push on the front of the rocket, pushing it forward. This creates an equal and opposite push on the exhaust gas backwards. The force applied by ROCKETF and reaction force R are responsible for upthrust of rocket.